So we already have an effective SEN exam tool for speech to text. For example, the quick brown fox jumps over the lazy dog. And this can be used by students who have appropriate provisions in exams. However, we wanted to extend support to partially sighted students and others with screen reader requirements, since these are not done very well at the moment. The results were acceptable, but the default voice was somewhat robotic, and the system read from top left to bottom right without any grasp of the question's intent. It felt like something that might have been really impressive in the 1990s, but less so now.
Shown below is a right-angled triangle, not drawn, x, accurately, 6 centimeters, 8 centimeters. Use Pythagoras theorem to work out the value of x.
So we then processed the output through an interpretation AI and upgraded the voice to something more natural. And the outcome is very encouraging, a clear contextual description of what was on screen, rather than a monotonous recital of words.
Shown below is a right-angled triangle, 6 centimeters, 8 centimeter x not drawn accurately. Use Pythagoras' theorem to work out the value of x.
Then we integrated OCR data and asked the AI to synchronize the speech with on-screen highlights. And you can see that the results are genuinely impressive.
Shown below is a right-angled triangle. The triangle has sides labeled 6 centimeters and 8 centimeters, with the hypotenuse labeled x. Not drawn accurately. Use Pythagoras' theorem to work out the value of x.
And you can reselect an item or an area and have it play it again.
Shown below is a right-angled triangle. The triangle has sides labeled 6 centimeters and 8 centimeters.
And just out of curiosity, we also tasked the AI responsible for our generated questions tool to produce worked solutions.
We have a right-angled triangle with one side measuring 6 centimeters and the other side measuring 8 centimeters. We need to find the length of the hypotenuse, labeled as x. Using the Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the other two sides, we can write the equation as follows. Calculating the squares of the sides, we have 6 squared equals 36 and 8 squared equals 64. Adding these values gives us 100. Taking the square root of both sides, we find that x equals 10.
This, of course, is a step too far and not something that students should have access to. But the output was surprisingly good. For now, though, most LLMs struggle with maths and science, despite appearances, and we won't include this. Perhaps a feature for a future release. If you think this would be a useful tool for your school, please get in touch. If you can think of something that we could do better, please leave a comment below. And here are some more examples for those that are interested. It shows what the current AI capability is. These might be useful tools for teachers on occasions.
The map shows the Indo-Australian plate and the Pacific plate around New Zealand. The North Island and South Island are labeled, with major volcanoes and earthquakes marked. The epicenter of the earthquake on the 14th of November 2016 is highlighted. The Kermadec Trench and Hikurangi Trench are also shown. The average annual movement of the tectonic plates is indicated as 37 millimeters and 41 millimeters in different areas.